In the last session, we have seen how to handle drop-downs in Selenium. So we have seen different types of drop-downs. So we have seen different types of drop-downs, how to automate them with Selenium we have seen, right? So like we saw single select, multi-select, and also we have seen like how to automate auto suggestion drop-downs, right? So in this session, we will discuss about how to handle web tables. How to handle web tables. So what's a table first of all? So a table is a combination of rows and columns. So a table is a combination of rows and columns. So when we divide it like this, these are different columns. So we can say this as column 1, column 2, column 3, and so on, right? And what are rows? So rows are like from top to bottom. So each horizontal division, right? So is one row. So it need not be same, right? Columns and rows need not be same. So it can be even like this. Can have one more row. So in this case, we say that it has 6 rows and 5 columns, right? This is row 1, row 2, row 3, and so on, right? So when we say about like, it will not be divided like this, but you'll have the data in this form. And we call it so we represent each cell like, say for example, this cell, say for example, this one, right? A row 2 by column 3. So that's how we represent this part, this portion, or we call it as cell, right? So, and how do you represent this table is, so by its number of rows, say for example, it has 6 rows by, we call this as cross mark as by, and 5 columns here, right? So we say this table size is 6 by 5. That is row size by column size. So this is the understanding of a table. So I think we have seen this as part of multi-dimensional array. Multi-dimensional array we have seen, right? So in Java, when we are learning multi-dimensional array, so we have seen this. So now it is again the same like multi-dimensional array, right? If you take two-dimensional array, so this is how the elements will be stored, right? So in the same way, like we do for a table also, we do have rows and columns. A table is a combination of row and a column, right? All rows and columns. So it can have n number of columns and m number of rows. We represent like this. First number will represent rows and the second number will represent 5. And in between, there will be a cross mark or X, right? So we call it a 6 by 5, right? So this is a table. And each cell will be represented by its own row and column, right? So this is a high level understanding of a table. All right. Now, okay, so this is a high level understanding of a table, right? So the same thing, when it is present in a web page, it is called a web table. So a table present on a web page is called a web table. So there are different types of web tables. So static web table, dynamic web tables, two types, static and dynamic. And other kind we can say is like pagination. So static, dynamic, or let's take this also as one kind, pagination web table, right? So three types. So we'll see one by one now. So what's a static web table? So first, let's start with static web table. Let me clear this. So you see a table here, right? So this is called static web table. Why we call it as static? So the data is fixed. So it has headers. Headers is like you can say it as column names, and you can see here the data inside it, right? So this is what we call it as a web table, and it has data in it, right? So it's in a table format and it's in a web page, so we call it as a web table. So now it is called as a static web table. This is because the data in it is static. So it never changes. It always stays the same. So even if you refresh the page a number of times, this data will not change. It is fixed. The data is fixed, right? So this we call it as static web table. When the data dynamically changes or whenever you refresh, the data will be modified, right? So it grows or it is modified, right? If it is stringed, then we call that table as a web table. Or if the existing data itself gets changed, maybe the number of rows and columns remains the same, but existing data will change. Even that we call it as a dynamic web table. So this, whatever we are seeing here is a static web table as the data is fixed. It is not gonna change even on page refresh, right? So this we wanted to automate. So how do we automate this? Right click on this page, inspect, and let's inspect this table. So if you hover on this, so if you see here, when I select this table, so it has a tag called table, right? And it has ID, table one class equal to some class, right? So this actually selects the whole table of it. Okay, let me put it on the right. Yeah, if you see here, this table, if I hover on this, so the whole table is selected. So this using the table tag, the table has been constructed, right? So under it, it has two tags, header tag, t head, meaning table header, and t body, table body, right? So under table, we have two tags, t head and t body. T head representing headers and t body representing the data. Again, like if you expand t head, so if you can see tr here, one tr. So tr represents table row. So this is all terminology of HTML for designing a web table, right? So tr represents table row. So if you see under tr again, there is th. Th is representing table header, right? So one header. If you expand again th, there is a span tag under it. So it's a last name, right? So last name is the label. If you see one th tag or one table header has been defined under tr, under th. So th is representing table header. Under it has one row. So tr, under tr, we have multiple th. Each th representing one header. Header in the sense column here, right? See, like this. So then go for T body. Let's go for T body. T body is table body. If you expand it again, each row is represented with one TR. See, again, if you expand one TR, so it will have TD in it. So for table head, it will be TH. TR will be common, table row. But for head, that is headers, we'll have th tag, and for data, we'll have td, representing table data. So if you see, if you hover on each td, so it is representing one cell within that row. So this is one row and tr. So you can see it's been, it's been put in one open tag and close tag within tr, right? So within that we have tds, right? Different tds. So this last td, that is table data, last column data is having two anchor tags, two reference links, right? Like this is about first row, right? Which is represented with first tr. Like that, we have second tr. If you expand it, so the second row will be represented with second tr, right? It has its own tds because it has its own data, right? Like this. And if you wanted to go to the third row, third tr, fourth tr, like this. Each row is represented with one tr tag, and underneath it, we will have td tags, each td representing one column, right? So like this, if you have like n number of rows, you will have n number of trs. Underneath it, each tr will have tds, each td representing one number of, each td representing a column, right? Like this, again, we can have n number of columns. So each column represented with td. So once we take one tr, it will have n number of tds, each representing one column, right? Under T body, again, we can have n number of rows, each represented with tr, right? So let me put it here. Say, for example, something like this, and the hierarchy is like this. It will have T head. Under T head, we will have tr, a close tag of tr, and within it, we can have T heads. So again, we can have T body. Within it, we can have n number of rows, each represented with one tr, right? So if you see, table body will have multiple TRs because it can have multiple rows. But table header, right? So header is one row. So with one row, we can represent the column name, right? So we have only one TR under it. It can have n number of columns, so we have multiple THs under it. But table body is not like that. It can have n number of rows. So each represented with one TR, like this, right? So this is the hierarchy. Okay. So represents a table. This this represents a table, right? T body, T header represents table header. Represents table header row because this tr is under T head, right? So in the same way, like this is representing table header column, you can say. Like this is representing table body or data. You can say table body. This represents the table data row. This represents table column data, or you can say row data here, right? This you have to remember. So using this only, we will be inspecting the elements and capturing the data, right? So this I did not put, but you can understand it something like this. Okay. Under this will be closed like this. And we have to close the T body, right? And we can close the table. So this is how the hierarchy will be, right? So, and this is description of each tag, right? So using these tags, we will be able to locate the elements as well as fetch the data. Now let's go back. Now if you see, so it has the same structure, right? So table header, table body, under each table T head is one tag, which is representing header, and underneath it we'll have one TR, which represents the table header row, and underneath it we'll have TH. In the same way, we'll have T body, we'll have one TR representing each row, and under TR we'll have multiple TDs, each representing a column, right? All right. Now with this, yeah, with this knowledge, we can start automating the web tables, right? So let's actually inspect this table first. Let's start creating the. So what we wanted to do, we wanted to actually retrieve the data from this table, from this web table. That is what we are trying to automate now. So for that, let me create a new package for today. We'll call it as day31. We'll create a new class. We'll call it as static web table. We'll create a WebDriver instance and we'll instantiate to Chrome driver. And then we'll maximize the window. Or we can actually driver.to get pass the URL first. We'll navigate to this URL and then we'll maximize the window. Manage dot window.maximize, right? All right. So this navigates to the particular URL and it will actually, what it does, it will navigate to the URL and it will maximize the window. All right. So now we have to find the table, right? So let's find the table. So we wanted to actually print all the rows, right? So how do we do that? So let's actually find the first row. Say for example, I wanted to print this data, right? So first let's actually inspect these elements. Okay. So if you see, it all starts with this table, right? And it's a T body. So we can actually try displaying the table data first, right? Table data. So go to selector sub. So if you see, all right. So if you see, it is a T body, right? So if you can select this, it is matching two tables because it has another table underneath it. So we have to specify some which T body we mean, right? So you can say T body of one, or we need to specify the table first, right? So this is the table. So you can get the table ID first. This is the table. Underneath it, we want the table body is what we are seeing here. So this will select the first table, right? So with this ID, we are able to identify the table. So this is our T body, right? And then if I wanted to capture all the rows, so we wanted to record, we wanted to read all these rows, right? So under T body, we have TR. See, so if you say /TR, so which is under this T body, right? It actually is representing all these 4 rows. See, 4 elements matching, right? So we'll iterate it like this. TR of 1 will represent first row. TR of 2 represents third row, second row, third row, fourth row, like this, right? And again, say for example, I wanted to read first record, right? First row. So this will be the XPath for it. So this is how you need to construct it. So let's go back and try to find this element by dot XPath. So this is one. So you should not represent TR. When we say TR, it will give you the actual TR, all the TRs within this table, right? So TRs is rows, number of rows. So it will be find elements because TR is representing rows, right? So it will represent rows. Now we can actually capture the size of it. So find elements dot size. So find elements dot size. So it will give you the actual size of how many rows we have, right? So it returns integer. So you can capture that into rows. So this is rows because this whole path is representing number of rows. So you can go back and check that as well. See, so this is actually matching 4 elements, each one representing, each TR representing one row, right? All right. Now, so we have captured that into rows. All right. Now we wanted to print all the rows of the table. So how do we do that? Where int I equal to 0 or each one starts with 1, right? So we will represent it with 1. Less than rows. Less than or equal to rows. So if you see, this is not an index, right? So this is this each one representing one row, one row here, right? So rows. So we found the size of this number of rows, right? So with this, we got the count of rows. Now we wanted to iterate through all the rows, right? So we have taken a for loop. We have written a for loop with index I, right? I equal to 1, each representing one row till all rows are completed. We wanted to increment row by row and perform some logic. So what logic we wanted to perform? So for each row, we wanted to visit each column, right? So how do we actually represent the column? So first we have to represent each row, right? So driver dot find element by dot XPath. So we can get this as is, and then observe now carefully. So what we are doing. So we wanted to pass the row ID, right? So row number dynamically. So this is how we can pass, right? So see, for example, I wanted to have first row, right? TR of within square braces, we need to pass the row number, right? So that is how we are doing. But I will be changing dynamically, right? So this is the reason we put it in a loop, right? So this I, as the I value changes, so the row will be changed, right? So this is how we represent it. So this is nothing but this one. So whatever we have seen here, right? TR of 1 like this. TR of 2, TR of 3 like this. So if you observe, the same thing is repeated, right? So only this number changes. So we have put it as a variable. So whatever is changes every time without the change in rest of the path or rest of the string. So we'll have it as a variable and we'll put it in a loop, right? So this is what we learned when we are learning the looping statements, right? So that is what I have done here, right? So this actually represents the row. So as the I value changes, it represents a different row. All right. Now find element is returning web element. So let's capture that into a web element. So each one is a row. So I just put it in a, I'll just call it as a row, my row, right? So now for this row, what we wanted to do, we wanted to read each column, right? So each column. So how do we represent, how do we actually get the column for it? So for this, you can say that it's a size. So instead of getting the column, we'll get the size, it's size, and we'll put it in a variable called columns. Columns j plus y. So instead of getting the web element, what I did was, so I wanted to get the size of it, right? So get size, get size. Yeah, this will be find elements, and this will be, yeah, even this will be get size. Find elements dot, no, size, right? Sorry. So we wanted to actually represent all the elements. So all the rows dot size, which gives us the count of the rows. So in the same way, for each row, right? So for each row, what we wanted to do, so each row is represented with this. But for each row, once we enter into it, so say for example, for the first iteration, this will be representing first row, right? Dot size. When we say dot size, so it actually represents the column. So, but we have to actually modify this, right? Like slash td. Actually, this represents the columns, each column, right? So now we thought of getting each column with this first, but we need to get the columns, right? So column is represented with TD, right? So TR, and we pass the row ID here slash TD. This will represent the column, all the columns. Say for example, so row is already done here, right? So we are done. Now we wanted to actually capture the table data. So say for example, so this TD is representing a lot of data, right? So say for example, I wanted to read first row data, tr of one I passed slash td. So these 6 elements will be selected, right? So within the first row, we wanted to read each cell. So slash td is representing the each cell. See, you have 6 elements matching, right? First row, because I have passed 1 to tr, right? So then td has 6 matches. So how do you get each value? Again, we parameterize it. Td of 1 represent the first column, td of 2 second, td of 3 third, and so on, right? So this also we need to parameterize it. So how do you do it? First, we have to find the count of the columns, right? So like how did we find the count of the rows like this, right? So in the same way, for the first row, we are finding the count of the column. See, the same way, right? So we just added slash td because we wanted to get the size of the columns, right? So this actually gives you the column count. Now we loop through it again. We loop through the columns. So j is representing one index. So this index will run from 1 till all the columns are completed, right? So for each row, we actually first we get the count of the columns, and then till all the columns are completed, we wanted to read the data. So that's what we did here, right? So if you observe TD of, say for example, TR of 1 for the first time, it represents the first row here. You have to observe this, which is highlighted in the left, right? So TR of 1 slash, no, when we say TD, it represents 6 elements, right? So we are trying to reading each cell now. So how do you read it? Slash TD gives us the count 6, fine. But we have to look through it, right? TD of 1, TD of 2. Only then you'll read the each column value of that particular row. So that is what we are trying to do now. So for that, reading the columns, we have written another loop within the for loop. So this is what we call it as nested for loop. I loop represents rows, right? So in the same way, index I represents rows, right? So in the same way, index j represents columns. All right. So one loop for rows, another loop, we find the column size, and then we loop through all the columns within that row, right? Now, how do we find the data for each cell? Find element, that is this one. We wanted to automate this TD, and then the variable part, this part, right? So here we wanted to pass it as J, something like this, right? So we can get it here by dot XPath. So you can get this part as is. Or you can get it from here. This is by dot XPath, right? And then this we need to parameterize it. TD of plus this will be J, and then close the square bracket. This actually gives us the actual text, right? This is the web element, right? So this is the web element which represents the cell. So I representing a row and J representing each column, right? So once it is for the first row, what happens? This will be fixed. It will be 1, and this loop changes the value of J each time. So each time J changes, right? So each time J here changes, it actually represents one record, one cell within that row. See, third column, fourth column data, like this. Like this, we are looping it, right? So as it will be changing every time, we have just put it a variable there, and we are looping it through, right? All right, now we have this data. We are representing the web element. We haven't get the text out of it, right? So let's get the text of it. Get text. String of, I'll just call it as cell value. Each cell value, right? So only when you say get text, so till this part, find element, what it returns web element. So on top of that, when you say get text, only then you get the text of that web element. So I got the get text. I used get text method to read the text of that particular web element and have stored it in a cell value, as get text method returns a string value. All right. Now if you see, we have the cell value. What we wanted to do, we wanted to print it, right? So you don't need to write the println. We'll use print function because we wanted to display it side by side. So after each cell value is displayed, we don't want it to go to the next line. We just wanted to have it side by side. So what we can do for that is, I can just print the cell value and then have a space here. So you can have tab space like this, or you can use /t, which actually will give a space of tab, right? So a tab space will be given before actually printing the next cell value. All right. So once we do this, right? So we actually displayed the data. All right. Now what we wanted to do. So like this, what happens? This actually representing each column, right? So what happens for each column? So for each column, TD will, so for TD, this will be repeated. The J will be looped. So the cell values for that particular row, say for example, for the first time, 0th row, right? So it will be modified, and the text will be captured in cell value, and that is displayed. That's all, right? So once we read all this data, say for example, 6 elements, right? TD was representing 6 elements for the first row. TD of 1, TD of 2, like this, we'll read it. After reading all the TDs, then what should happen? It should come out of the this loop, right? So 6, j less than 6, right? So it has to be less than or equal to 6, because it has to run from 1 till 6 columns, right? So once it is done, so it will come out of this first loop, j loop. Then what should happen? Once it comes out of the loop, so we are going to the second row, that is this loop, right? So I plus plus second row. So before going to the second row, we wanted to actually print a line here, new line, because we wanted a new row, because we wanted to print new row in a different line. So we are displaying the new row, new line here after printing all the cell data for the particular row, right? So I'll just repeat it again. So this represents one index representing the row here. And for each row, we are calculating how many columns it has. And then we are looping it. We are having another loop, which is representing with j index. So j is representing one column here. So till all the columns are completed, we are displaying the cell value. We have written a small logic here. So to loop through all the rows and all the columns for that particular row, right? So I and j were used for that. And we are displaying the cell value here. After displaying all the cell values for a particular row, so as next row, in the sense, it will be in the next line. So we are actually having a system.out.println. So what happens after this? So it will actually continue to the I2, second row, right? Second row data and second row columns will be calculated. And, for the second row, this loop will be run. So for the second row, the table will be read and it will be displayed. And after it is completed, again a new line will be this. So to have a new row, so we just displayed a new line. And then it goes back to the third row and so on, right? So that's how the data will be displayed. All right, so first let's execute this till here and see. So when you are automating WebTable, it's all about like writing the logic than the core concept. So how do you actually handle it? By, it's all about rows and columns, right? So you need to handle it by writing the logic, right? Logic. All right. Yeah. So if you see, we got the data here, right? So Smith, John, J. Smith, $50. And yeah, you can compare the data here, right? So it actually displays everything. Yeah, it is also displaying something called edit and delete, which is a link, right? So which are the actual links. And if you don't wanted this, right? So this is in the last column, 1, 2, 3, 4, 5, sixth column, right? So if you don't wanted to have this displayed, you can just have this run only columns -1, so that it will actually, for each row, it will display only columns -1. That is, in our case, columns is 6, right? 6 minus 1, 5. So j less than or equal to 5. So it will run only for 5 times. So it will display till the website, right? All right. If you go back, yeah. So you can see that column has been dropped now because we are reading for each column. So for each row, we are actually reading from first column till the last -1 column. So that's the logic we have written here, right? So it actually skipped the last column. All right. So till here it is fine. Now if you observe, we are missing something here. What are we missing here? So if you see here, we are missing the headers. So because we didn't write the headers part here, we started by reading the rows with T body, right? Now we wanted to print the headers. So what we can do, we can actually take something like this and have T header, TR, and then we can use TH for actually writer loop to actually have the T headers. Or simply what we can do is, so anyway, that TR within the TH is only one, right? So if you see here, under T head, right? To T head. So only there is one TR. And underneath it has multiple TH is representing one table header, one column header, right? So instead of actually having this written in a loop, right? So what you can do is probably we can even print it like this. So anyway the column names, right? So if you wanted the headers, you can just hard code it, something like this. Slash T will actually leave a tab space, first name, email, due, website. That's it. Okay, this should be slash T, slash T. No. Now if you see, we will get the table headers as well. We are just displaying, we are just hard coding it because it's a static table, right? Anyway, it's not gonna change. The data headers will not be changed. Or else, in general practice, what we usually do is we have to loop through it. Like how did we loop through this records? So in the same way, this line will read, right? And instead of T body, we'll have the T header. That way we'll get the rows. Rows will anyway be one, right? We know we only have one TR under T head. So it will be one. And then underneath it, we'll write a loop again, like same like this. Yeah, you can see the data, right? So with the headers now. So you have to just align this correctly. So you can just adjust it, something like this, right? So tab is tab. So here, maybe you have to provide two tabs like that. So if you want the headers, that's how you need to write the logic. You need to again write a for loop, and within it, you'll find the t head tr count. And then for all the rows, that is anyway one row. So you'll calculate the columns in the same way. This will have t head, that's all. Nothing changes there. And for each TD, you'll write again a for loop and print all the header values. Basically, you'll repeat everything, this till here, right? Except with T body replacing with T head. So instead of that, anyway, it has only one row, right? And which never changes. So I just put it as hard code. I just hard coded this values. So you can see the data here, right? So yeah, you just need to align it correctly. Maybe you have to give it some two tabs here like that. This is just anyway for our information. How do we retrieve the data, right? So this is how you actually read the data for a web table. Now, let's actually perform one action here. So say for example, I wanted to actually, okay, we have some number here, right? Due. Due is a number and it has different values. Okay, now I wanted to find the highest due value. What's the highest due value? So you can see clearly 100 is the highest due value. So how do we actually calculate it? Let's see how to write the logic for it. So for that, we need what the logic we are gonna do is, so we'll actually capture all this. So when we this due, right? So these column values, we'll add it to a array list, and then we'll sort it. We'll use collections.sort method and we'll sort it. So once we sort it, you will get this due uh, numbers in sorted order, right? So once you get it in a sorted order, so you will actually try to fetch the last one, last value. So it will be sorted in increasing order, right? So the last value will be the highest one, highest due. So that's the logic we are gonna write now. So let's see how to write that logic now. So first we'll declare run array list. Array list. So this will be our list of double values. I'll just say due values. This will be list. right? Now this div values, we wanted to add it. So how do we get it? So we don't need to write a separate logic or loop for it. So if you see, we are anyway displaying each cell data, right? So cell value, right? So cell value, we wanted to get it. So what type of cell value we need to get it? If the column is, so say for example, column is, where the column is present. So just before two columns, right? So from, if you actually count it from the start, one, two, three, fourth one, right? If you count it from the end, it will be one, two, third. So it will be third from the end, right? So what we can do is we can calculate the column size and then we can get the third column from the last, right? So how do we get it is, we'll write a simple logic here. If j is representing one column, right? J is columns minus 3, right? The whole column, so it will be 3, 4, 5, 6, right? So columns minus 3, in the sense, this will be representing the first column, right? From the end, second, third, right? So columns minus 3 should work. If my j is actually matching this columns minus 3, then I want to fetch this. I want each value of this to be added to my div values array list. Right? So let's capture that. So how do we get it? Again, driver dot find element y dot xpath, or we can get the cell value itself, right? Directly. We have the cell value here calculated for it particular, right? So what we can do is div values dot, how do we add the to array list? We use a method called add cell value. That's all. We anyway got the value, right? Here in the cell value, we are just adding that cell value to it. Now, so if you add it directly like that, it will not allow you, right? So it's a, so add actually accepts, see, and also we need to write some logic here. So if you observe, this div values also has, these are not the direct double values, right? So it also has some dollar symbol before it. So we have to replace it. And also there is a dot. So dot is fine, right? So this dollar, you have to remove it. Only then it will become the pure decimals and we can actually compare them. And we can call them as a double values, right? So how do we actually do that? So say for example, we have the cell value already. This cell value, we wanted to actually convert it into double first, right? So how do we convert it? Even before that, so this cell value, if you observe, it's a string, right? So you have to convert it into double. That's one part we need to do. And we also need to remove this dollar from this. Only then we can convert it into double value, right? So this cell value, first what we'll do is cell value dot, I'll say replace. I'll use replace method here. So replace is one string method. So I'll use dollar here and then we'll replace it with nothing, meaning we are replacing dollar, right? So if you write something like this here, so dollar will be replaced with hash. Dollar will be represented with comma like this, but I don't want it to have the dollar itself. So I'm giving empty string here so that this will be replaced. All right. So from this cell value, we are replacing dollar. All right. So how did we know that this will be definitely the div column? So that condition we have mentioned here, right? So if you observe here, that condition we have mentioned here. If my column is matching the columns minus third, right? Columns minus 3, in the sense it will be from the n, right? So we have columns here, column size represented here. So that size minus 3 will represent the third column from the end, right? All right. So I think columns minus 2, right? So if it is columns, it will be last column. Columns minus 1 will be the last but one. Last minus 2, columns minus 2 will be the last but one, two div, right? So it will be columns minus 2. All right. Yeah, I think this should work, right? So cell value dot replace, we are representing dollar with empty string. All right. Now we can actually parse it. Double dot parse int. So we wanted to do two operations here to the cell value. As it is string, so we wanted to convert it into double. So as we can't convert it into double as is because it has a dollar, we just used this value, cell value dot replace method. All right. So now it's a pure double. So now, but still cell value is of type string, right? So we have to convert that string type to double. So I'm using double dot parse double of. Parse double of, right? This value. Now we have this cell value converted into double. So we just replace dollar with empty string. So it's a pure decimal now. So cell value is a pure decimal and we are converting it into, but cell value is still of string data type, right? So we wanted to convert it into double. We wanted to compare it or sort it, right? So we use double dot parse double. All right. So now this will become a double value. So let's capture this into a double variable. All right. So this div value, we are gonna add it to div values. Div values represents array list, right? To this, I'm gonna add div value. Or you can just say it as list. This list of div values, we are adding a div value, right? All right. So once we add it, we have the values in the list div values, right? All the values, these values. We have it in the list of div values. All right. Now, what we wanted to do after this if loop, we wanted to, once we come out of this loops, right? This complete, all the rows are done. Then we wanted to write a condition, or we can just use collections dot sort method. So there is a method called collections dot sort. So collections dot sort method. So collections is a interface, right? Is a class, right? So this class we are gonna use and a method dot sort, and then we are gonna pass the div values in it. The list of div values. It accepts list. So if you pass list of values to it, it will actually sort it in the ascending order. Collections dot sort. If you pass the list of values to it, it will sort it in a ascending order. Now our list is prepared with double values which are in sorted order. Now, why did we are actually calculating all this? We wanted to get the highest due, right? So that is what we are trying to do. So this list due values has the due values in sorted order. Dot. So it's a list, right? So get of index we need to pass. So what index we need to pass? So we need to pass the index of, you know, this size, size of this, size of this list minus 1 because list index starts with 0, right? So you need to get the size minus 1 because the last item in the list will be represented with size minus 1 as the index starts with 0. So get of size minus 1 will represent the last element is in the within this list, right? And this list, what it has the sorted double values. So for that, for sorting, we use a method called collections dot sort. All right. So this actually will give you the highest due value. So let's run this and verify. So what did we do here? It's simple. We wanted to actually get the read some particular column. So for that, we have written this small logic. So anyway, we are actually displaying the data, right? So while displaying the data, we are checking one condition. If J is representing one column, right? So if J, when it becomes equals to column minus 2, so it anyway will run till columns minus 1, right? Yeah, you can see the highest due is $100, right? So it actually displayed that value, right? So yeah, so if it is equals to that columns minus 2, then what did we do? We actually use the cell value. So it will be representing that particular column, right? Due column. So we are just replacing this dollar with empty string so that we'll get the value in decimal, right? So this, but still the cell value is of type string. So we wanted to convert it into double so that the same value will be for when you look at it, it will be the same value, but it is of type string. So we wanted to convert it into double. So we converted it using double dot parse double. That we captured it into new value. And this we are adding it to a list of double values. Why we are doing this? We wanted to sort this. So in order to sort it, we need a list. So we are preparing a list here. So once we come out of this loop, we will have one list prepared, right, with double values. So that we are passing it to this sort method, which actually sorts the values in ascending order. So once the values are in ascending order, so how do you find the highest one? If you want the lowest one, it will be the first element in the list. If you want the highest one, then it will be the last element in the list. So how do you get the last element in the list? So you will get the size of the list minus 1 because index starts with 0. So it will be size minus 1 will be the last element. So that we are passed to the list itself. List dot get of index we need to pass. So we are passing, we wanted the last element. So we just use this logic. Size minus 1 will actually point to the last index. Get of last index from this list will give you the last element from that list. So that is all what we need, right? So you can see the highest due is, you can see that in the console. It actually displayed 100 correctly, right? So if you want, we can quickly, I can actually show you by debugging it. Or if you are fine with it, like then we can just go to the next topic. So this is how you usually automate a web table. Is that clear? First of all, till here. All right, perfect. So you can even debug it. Say for example, like you can just put it at the cell value, right? And let me show you for one iteration at least. When you do debug as, so when you wanted to debug, I just had a breakpoint here. So if you see toggle breakpoint at the 33rd line, and instead of run as, I did debug as, right? So now if you observe, the execution will be passed here. Control will be passed here at the 33rd line. So from there you can debug and see the values. Yeah. So it stops here, right? Now if you observe the find element, and yeah, let's check the value of values here. So if you see J is 1 here, and the current value of, or you can even see here, right? So I is 1 here, J is also 1 as it is a first iteration, right? So TR of 1, TD of 1 will represent, 1 will represent this one, Smith, right? So if you see here, cell value has to be Smith now. Yeah, you can see Smith has been displayed, right? So now if you observe, J is 1 here. What's the column's value? Column is 6. 6 minus 2 is 4. Is 1 equals to 4? No, right? So it should not enter into this if condition. Yeah, it just skipped and it went back to the for loop. So for the second time, what happens? J will be 2. So this will be, row will still be 1, right? But J will be 2 this time. See, TR of 1, TD of 2. So first row, second column. First row, second column is John, right? So that has to be displayed now. Yeah, see, John has been displayed and so on, right? So still j loop is still there. So I will be constant, tr of 1. So the third value of j has been displayed. Now observe, j is 4 now, right? J is 4. So what happens now? The value div has been displayed. All right. Now this 6 minus 2 is 4. J is also 4. 4 equals to 4. Now observe. So it enters into the if condition. Now this logic will be executed and you can see the div value here. So if you see here, this div value has become 50.0. So the dollar has been replaced, right, with an empty string. So it is pure decimal now. So this decimal, we are adding it to the list of div values. List of div values is a type double, right? So that's the reason we converted it into double, and it can accept the div value as it is now double value, right? So once you add it to the list, you can even see the list here. So one item has been added, 50 has been added to the list, right? So in the same way, like, instead of having, so let's actually go through the second row. So I'll show you. So once this is done, so TD of this website has also been displayed. Now J becomes 5 and it has to come out of the J loop. See, it will come out because all the data has been displayed for the first row. Now it has to go to the second row. So it is actually displaying the new line. It is in the second line now or second row. So now I value changes. So I value is 2 now. So if you go here and hover on this, I becomes 2. And for this, columns will be calculated. So columns will be again 6, right? And again, the same part, right? So for the second row, the data will be displayed. So again, when j becomes 4, what happens? It has to enter into the if condition. It will add to the list. Now, if you observe the list values, it will have 2 values and so on, right? So for each row, you will have one list value added and so on. Yeah, if you go on like this, so then it will actually, I wanted to execute it. So yeah, you can see this, right? Finally, it will actually sort it and then it will actually display this value. So like this, you can debug and verify even if you are not getting this, right? So how the logic is working. So it's simple actually. So whenever you wanted to display rows and columns, not only for this, anywhere. So you can just remember, like, you need 2 for loops. One for loop, actually the outer for loop is for rows, the inner for loop is for columns. And then your own logic inside it, right? So simple. So hope you got it. Now, if you are fine with it, then we can just go to the next topic. So how do you automate dynamic web table? Yeah, I've shown you how to debug it. So yeah, whenever you have like a bit, lengthy logic, so it's always better you debug it and verify the values. Then you'll get a clarity. All right. So now uh, let's go back to dynamic web table. So we'll start dynamic web table. So this is all about whatever we discussed till now is a static web table. So in the static web table, you can even, like, the rows and columns will be fixed, right? So you can even write this statement outside of the loop as well, and have this tr value, any of this value, tr of 1 or tr of 2. For any row, the columns are fixed, right? So you can put it before the loop also and have the columns, you know, calculated way before you enter into the looping. As a columns for any row are fixed, right? So you can even do that way as it is a static web table. All right. Now let's actually see the next one, dynamic web table. So how do we automate the dynamic web table? First of all, what is dynamic web table? Let's discuss that. So for this, so if you see here, this is a dynamic web table. So it has name and, it's like a process name, or it seems to be a browser name, but it also has system. So it's a task manager actually. It's a task manager, and each task is represented with its name and how much CPUs it allocates, disk space, how much disk space, like how much CPUs it is using, right? How much disk space, how much memory it requires, and what's the network speed, right? And if you see this, these values are not fixed. So just observe this at least. Chrome CPU 7%, right? So you can see Chrome here, CPU is 7%, right? So if I refresh this page, this will not be the same. It changed to 8.5. If I refresh this page again, so it will be different each time, right? And also, if you observe the column names also, right? So name will be fixed, but if you observe these columns, observe it is disk at the first and memory at the last, right? So if you observe when I refresh, see it completely changes. The headers are also changed dynamically, right? So each time it is not the same, it is not fixed. That's the whole point I wanted to convey here, right? So the headers are not fixed. The order of the headers always changes on page refresh, and also the values are dynamic. It always changes. So you can see it at least with this value, it is changing every time, right? So how do we automate this kind of web tables? So it will be more or less like how do we automate it like a static web table, but as this is dynamic, right? So for the dynamic tables, we also will have something like to verify. So to validate, so we wanted to validate this value as this changes every time. So we wanted to verify this value if it is correct or not, right? So if this is displayed correct or not from the task manager. So how do you actually validate it? You do have this value here as well, right? So name Chrome CPU. So under CPU, we have this value 9.1, right? So we wanted to fetch this value and compare it with this value, right? 9.1. If it is equal to this one or not. So that's what we wanted to achieve now within this dynamic web table. So how are we going to do that? So we'll see that now. Let's automate it. I'll create a table, create a new class. We'll call it as dynamic web table. In the interest of time, I'll just copy this 3 lines, which actually launches the Chrome browser, navigates to the particular URL, and also maximizes the window, right? This is different. All right. Now again, like we'll start locating the elements, right? So right click, inspect. If you inspect this again, right? T header, T body, table. This time table doesn't have ID, it has some class, right? So, but that's fine. So if you go to selector sub, it will give you the related XPath. So just get that related XPath and have the table here, right? So this time we will write the XPath different way for the elements, right? So XPath by dot XPath. This is actually representing the table, right? So I'll have this. This is a find element, right? So it has to be captured in the web element. This is fine. Right now, what we'll do is first, like we'll actually have we'll display all the columns as usual. Okay. For that, we have the table, right? So we have the table and we wanted to find all the rows. That's what we usually do, right? So before starting the loop, that's what we do, right? So first let's find the number of rows. So for that, I'll use table dot. So if you observe, we'll do it a bit differently. So if you observe, I'm using table itself and using find elements method. So what is table? Table is a web element, right? It is representing web element. On web element, it also like web element is also an interface which also has the find elements method. See, find elements method is supported. Again, like here, you can continue the XPath. So table is represented with this XPath, right? So on table, you'll use the find elements method. And here you'll use this one. By.xpath. We wanted tbody /tr. That is what we can see here, right? Tbody, and it has tr second. See, each tr representing one record, right? So how we can write the XPath is, so this path /tbody /tr will represent the four elements here, right? Four records, four rows here, right? So what we can do, we can use table. Table is a web element. Observe carefully. Dot find elements. By.xpath. I am not actually providing this path again. I am writing XPath only, but not providing this, right? So I'll just continue the XPath because table is already representing this whole XPath, right? This XPath. So we can use table web element dot find elements by.xpath, and we are just continuing the XPath /tbody/tr, which is representing rows, right? Find elements. So it is representing list of web element. It will return list of web elements. These are representing the rows, right? So only new thing we did was, like, instead of repeating this whole path, what we usually do. So if you observe in the last example, what did we do in order to represent it? So we had this rows, right? So we didn't have the table, but we had this complete rows. And now we are repeating this every time till here, right? Like this. Everywhere we repeat it. So we are just, it's a redundant code, right? So we are always need to have the redundant code optimized, right? So we always need to write the optimized code. So for that, what we did was we actually captured table in a web element, and we use table web element and using the find elements method to find all the rows, right? So we are not going to repeat this again, this XPath. So we have the rows now. All right. Once we get the rows, what we can do, we can start writing the loop, right? Where int I equal to 0. Now we'll start with 0 because we have a list of web elements, right? So rows dot size I plus plus. So rows dot size. I'm not using rows dot I less than or equal to, right? Because index starts with 0. We are in list now, right? And we wanted to display all the rows. So we have seen the logic. So for the first row, like once we have this I for rows, so what we do, we actually calculate the columns. If you go back, so what did we do? We calculate the columns for each row, right? So let's do that. So now observe how I am gonna calculate the columns. Rows dot, now this time I'll use rows dot find elements. Okay, rows represent list, right? List of rows. So in order to get a particular row, right? Rows dot get of I represents one row here. So I is representing row. Get of I represents, say for the first time it will represent first row, right? Dot find elements. So for the first row, get of I represent rows, right? Say for the first time it will represent first row. Get of I row dot for the first row dot find elements. What I wanted to find, the find elements method will return. So we wanted to write an XPath so that we wanted to get the TDs under that TR. So here we are, right? Here we are, and we wanted to have all these TDs. How do you write it? So under TR, say for example, TR is representing all the four elements. So for the first time, TR of 1 will be there, slash TD will represent all the 5 elements within the first record. So each element representing one cell, right? And again, you can loop it like this, right? You can do it like that. But what we can do is, the web element itself, each row itself is representing one element, one web element here. So you don't need to write the indexes here, right? So rows, So rows dot get of I, which will get you the index of the from the list, not from the web table, right? So we are not using tr of 1, tr of 2, tr of like that. We are not using the index within the trs or th. For the tags, we are not using the index for the tags. Instead, we are putting them in a list. So it is much optimized, right? So when we iterate through the Java objects, right? So rows, we have had the web elements in the list of web elements, that is Java's list, and then we are getting that rows by using the get method. All right. So once we get the row dot find elements by dot xpath of. So as we are using, so say for example, this is representing one row. See, right? So on the top of that web element, we are using find element. Same like here. So you just need to continue the xpath. You can just put it something like this /td. That's all. You don't need to repeat this again, right? So it is anyway representing one web element of each row, right? So that's all. Find elements of /td will actually give you all the columns, list of columns. Find elements returns list of web elements, right? So list of web elements. So find elements, so we'll get all the columns. So it has become very simple now, right? Now from here, it is routine, like same. As it's a list, we wanted to iterate through this list, j less than columns dot size, j plus plus. This is to represent each column, right? So here you can actually print the value. Columns dot get of, what's the index? J dot get text. And then you can have some tab space. So once you are done with that, so we wanted to have a new line for each row, right? So that's it. See how optimized this code is. We haven't come to the dynamic nature, so we'll come to that later, but see how it has become very simple, right? The code looks very simple now, optimized. You don't see this everywhere, the tags and the HTML code. So it is, the XPath has become simple because we captured the table here, and then from there, we actually continued the XPath instead of repeating this whole part again, right? So this is the reason we actually are not calculating the size, right? So we are putting them in the list, and then dynamically we are actually calculating the size in the loop, right? So it has become very simple now. Or yeah, you can see here find elements dot td. Td actually represents columns. Get of a here is representing a row, right? For each row, find the elements of td. Or if you have like if you wanted to find multiple elements, right? What we usually do, we actually do use tag name. If you remember, we use tag name to get all the tags represented with that, right? So you can even use like this tag name. So I have one row called tr. So underneath it, I have some tds. So I have to get all the tds. So how do I get it? So each one has the same tag td. So in that case, we can use tag name. If you remember, this is what we did. So I wanted to get all the tags which has td, right? For this row, particular row. So what is this row? This row is anyway representing this one, right? Table dot find elements. What is table? This is this one. So finally, it will be constructed like this. This one, td tbody tr/td. So that is what we have here, right? So this whole part we have divided into multiple parts here, right? So multiple parts, and wherever is we require it, right? So which actually represents the again the cell value only. So till here we get all the columns, and with these columns, so this columns has no is a list now, list of web elements. So columns dot get j will actually give you the particular cell value. Dot get text will get the actual text out of that cell, right? And this is again the same, like this for loop is for columns, this for loop is for rows. And again, after all the data is read for the particular row, so we'll have a new line. New line for next row, right? That's it. So let's run this. We perform the same action, like we just wanted to display the output of it, output of this dynamic web table, right? So now, so that so the same logic we have written. So nothing new here. So if you observe, it is giving Firefox. Okay, it is giving in each new line, right? Every time after displaying this. Okay, so go back to the dynamic web table. So if you see here, okay, so we need to have this print, right? So after printing each cell value, so it has to be displayed side by side. We don't want it to be having in the next line. So we have to give it as print. Print method used as we want all the cell values, all the cell values of the row in same line. Right? So earlier we had print ln, so it was displaying each cell value in a different line. But so to view, so to display, right? So how we wanted columns of each row to be displayed in the same row. So we don't wanted it in a separate line. So I just removed ln here. Now if you observe, yeah, see, this is the output we were expecting, right? Firefox, Internet Explorer, Chrome system, and the values are anyway dynamic. So that's what we have seen here, right? So the values will anyway be dynamic. All right. So if you see here, we got the output in our desired format. All right. So till here, we just read the table and displayed rows by columns, data in a row by column format. All right. Now, what we wanted to do, I wanted to display the headers. So if you observe the output, it's not, so if you observe the output, so it doesn't have the headers, right? So these headers are not there, right? So I wanted to have this headers displayed. So I can't hard code it like how we did it for static table, because if you observe memory and the memory, network, disk, CPU, right? So it will not be in the same order again if I refresh it. So the column headers are changing every time. So we can't hard code this header value. So how do we write it? We have to write the loop here, or we have to actually print it based on the T header, right? So how do we do it? So now observe, we wanted to display the headers. So what we'll do is, again, we'll use table dot find element. I'm using element here. So I don't need, I know it has only one header, right? So find element by dot xpath slash slash. So it will be T header this time, right? T head slash tr. So what we wanted to display? We wanted to display headers. So for that, so I'll be using the same table. Table will be the same, right? But the XPath will be different. I'll start for T head. T body was for data. For T head, it is for headers and slash tr. So I know it has only one tr under T head. So if you see here, T head and T body. T body, we are completed. We are done with it. So I'm not expanding that. So coming to T head, so if you expand it, it has only one tr, right? You don't need to have the find elements. Even there is nothing wrong if you have find elements, but we know that it has anyway one tr, right? It's a table header, so it has one tr. Tr is one row. So I'm using find element. We'll capture that into a web element. So we'll call this as, we can call this as some header row. It's a header, right? It's a header row. Now, using this header row, we wanted to get the all TH. We will not call under TR, it will not have TDs. As it is header, it will have THs. So multiple THs are there, right? So let's capture that. So how do we capture that? Header row dot. This time it will be elements because it has more than one TH, right? So by dot XPath, you can have something like this slash th, right? Which actually gives you all th underneath this tr. Tr is represented here. Using that, we are using find elements to get all these th. Again, under this tr, there are multiple th, and we wanted to capture all of them, right? So you can just use tag name here. Both are same. Just for your information, you can even have this XPath as well. This also works. But anyway, we wanted all the tags to be read under it, right? So I'm using tag name, th, right? Find elements. This is find elements. So again, it will be list of web elements. This will be headers. So we have the headers now. Now we will use this to print, right? So for all the headers, I will be using, I don't need the index here. I wanted to display all the headers. So when we wanted to display all the headers, what we do? We can use the enhanced for loop. For each header from the list of headers. So what we wanted to do? We just wanted to print the header. That's it, right? So header, again, after each header, again, if you observe, so we don't wanted everything, each header in a new line. So we have to remove this ln so that all the headers will be displayed in the same line. So header dot, it's a web element, right? Header is a web element. So we need to get the text out of it. Text. And then you can have some tab space here like this. Or you can just have one tab space. That's all about alignment. So yeah, that's it. So what did we do here? To display the headers, we have written a small logic. But if you observe, we have used the same web element table here. But we have modified the XPath to point to the header this time, right? Which will actually give the header row. Using this header row, we'll again have the TH because TH will have one TR. So we didn't have the find element. So we captured it into one web element and we use that web element to find all the elements under it, which has the tag as th, because each th represents one header. So as this is find elements, we are capturing it into a list of web elements. As we have the list of web elements, so and we don't need any index. So we wanted all the headers to be displayed. So we just use an enhanced for loop to display all the headers. Now it has to display the headers as well. Headers and then data underneath it. Okay, let's go back. Yeah, you can see that now name, memory, disk, network, CPU, right? Internet Explorer, and then yeah, first row has been displayed in. Okay, so this is because okay, this also came in the first line because we need to. So once we display the headers, right? So once we display the headers till here, so this part has to come in the new line. So once we display all the headers till CPU, so once it come out of the loop, we have to leave a line. New line to display the data. Display data, display headers, display data, right? Yeah, it will come anyway in the next line. So we just use the system.out.println here. All right. Now let's actually solve one more problem. So if you observe, so we wanted to actually validate something here, right? So see this Chrome CPU, right? So this percentage, we have it here. So So how do you know the CP Chromes? So you have the name here. So under the name column, so you see Chrome, and under the Chrome, you see CPU percentage 8.8, right? So if it is the same, what it is displayed here. So if it is 8.8 here in this table, so it has to display in this label as Chrome CPU 8.8. So if it is same as it is displayed in the web table or not. So this we wanted to validate. So how do you validate? So first, what we can do for this is, so we can get the value of this 8.8 first, right? Then we'll compare it with this. So how do we get this 8.8 or this value here for Chrome? So we wanted to get the CPU value for Chrome. So how do we get it is, so we'll go through, we anyway wrote the logic for displaying all the data, right? Cell data. So now what we can do is, we can actually see, say for example, this Chrome is fixed, right? The value is fixed. And also if you observe, so if I refresh the column names, right? The column names, these four columns are changing, but this name is not changed. Every time it is the first column. Observe carefully. So it is always the same. So it is the same, right? And Chrome is also fixed. The value is Chrome. And the name is also always the first column. Observe, right? Name Chrome. Chrome might change the order, right? So it might be, order might be changed, but CHROME, the text is same, right? And also name column, it is always the first column in it. So we'll use that and to actually find this CPU value. Now observe, how do we write the logic? So we are anyway displaying the data, right? So what we'll write is, we'll have a logic written here. If columns represent cell values, right? Get of 0. I'll write get of 0 dot get text equals. If this is equals Chrome, can I write like this? Columns dot get of 0. Get of 0 will be representing the, so first of all columns. So columns is representing the columns, right? So columns. So if you observe, these are the columns, column data. So this was only for displaying the data. Observe carefully. Now we are concentrating only on the data. So forgot about the header. So the highlighted part you have to observe, right? From this, so when I say columns dot get of 0, get 0 indicates, as it is a list, it indicates index 0, right? The first one. Columns of get 0 will be indicating this. Within this data, it will be indicating the first column, that is Internet Explorer, Firefox, System, Chrome. So I'm checking if it is Chrome, is what I'm checking. If it is Chrome, then if it is Chrome, then we wanted to write some logic. What's the logic? Columns dot same 0, right? Find element by dot XPath. Now here we will use XPath accesses. So under Chrome, so this Chrome, right? So let's go to this, inspect it. So if you see here, underneath TR, this TR, we have multiple TDs, right? Data, each TD representing one cell data, right? So can I use this TR, right? So this TR, so underneath it, we have TDs, right? So if you observe, so columns dot get of 0, right? So this actually, what it gives you, it actually gives you the particular column, right? So dot find element dot XPath find element. Then what I can do is, so I wanted a sibling below this TR. I wanted a sibling, following sibling. All these are following siblings, right? So if you observe, get of 0 is Chrome, right? So under this TR, it has all the TDs. See, Chrome is also one TD. It has all the other TDs. All these become siblings to it. So when I say following siblings, it will represent all these TDs. Chrome is one TD, right here. So columns dot get of 0 is representing Chrome here, right? Dot find element by dot XPath. I wanted to write an XPath to have all these TDs. I don't want it to write a loop again. Instead, what I can do is I'll use XPath here. What I can do is following siblings is what I'll use, and I'll use contains if it contains percentile, right? So each TD has one representation here, MB for memory, right? MB per second is per CPU network, right? And disk, I guess, disk. Mbps is for network, like that. So percentile is for CPU. So we'll use this logic here. So let me show you first by writing here following sibling. So it will be following sibling. Sorry. And then following sibling, it can be any tag, but if it contains a text, what text it should contain? I'm expecting a percentile so that I'll know it is a CPU, right? So that type of cell I'm looking for. So if you see here, what did we do? Till here, it will be like, it will be printing each cell value. Fine, right? Column short get 0. What we get it? So the first column, right? The first column of the data. So the first column of the data is representing this one, right? Underneath it, what Internet Explorer, home system, file. In any order it can be, but it represents that. So as we don't know that order, we are written in if condition. So when it becomes Chrome, so I need this value. In the same row, I need this value, right? So for that, what we did, so get of 0, which will still represents the same column, find element by dot xpath. So within that TD, so this is representing TD, right? Column short get 0, TD. So find element of following sibling, which contains the percentile. If you say following sibling, it will match all this. So Chrome is what it is represented, get of 0, right? Because you can see here, get of 0 dot get text equals Chrome. So only then we are here. So column dot get of 0 will definitely represent the Chrome. So find element within that. So Chrome and find element of its siblings. Following siblings is all the siblings under it, right? So it will represent all these TDs as we say following siblings. But I need a sibling, right? I need a sibling which has contains the text as percentile because CPU load is represented with percentile. So if you find such XPath, then get the text out, get the text of that is what we are saying, right? All right. So this will capture it into a, it's a web element, right? So we'll capture that into a or get text, right? We have this as a get text. So we can define it here, but we wanted to use this somewhere else, right? So outside of the loop. So I'll just say CPU load. This is the CPU load. All right, now we got the CPU load. Now once we are out of this, then what we can do? We can compare the CPU load. So how do you compare? Driver dot find element by dot xpath. We get the xpath of that label. So we have this label, right? So this label, xpath of it is here, right? This label dot get text. This will capture value from the yellow label, yellow or orange, whatever it is. We have the text. So we'll capture that into some, we'll say it as value, right? You have the value now. You can just display the value as well if you want. And we wanted to validate this, right? So if this value dot contains whatever we calculated here, CPU load, if it contains this or not is what our validation is, right? So you can just say, CPU load matched. Else you can say CPU load not matched. Right? This is what we wanted. We wanted to validate this. So for that, we actually got the label here. So with this, so you can see here, this label, we got it with this XPath. So we had it that in a value. We are even displaying it. We will see that when we run it. So this value, if it contains the CPU load, how did we get the CPU load? We calculate it here, right? When it is Chrome, when the cell value is Chrome, right? Within that Chrome, so I wanted to find the element, web element, which will be its following sibling and containing percentile. And from that, I wanted to have get text, right? So this CPU load will have the percentage value. So that percentage value we are verifying here. So literally what we did was like we got this for Chrome, like we got this value first, that will be in the CPU load, that will be in the CPU load, right? And then we got this, right? So if this contains value dot contains this, if this label contains this value is what we are verifying. So it will if it contains that is 7.8, then we are saying CPU load match, right? So this is the logic we have used. It all depends on the requirement. So the requirement here was like we wanted to validate the Chrome CPU load, right? So this is the reason we are writing this logic. So you can write logic in different ways. So this is how we have written, right? So you can see here Chrome CPU 2.8%. So you can even verify it here Chrome. So CPU is the second column, and you can see this is the disk of it. This is the CPU of it 2.8, right? Chrome CPU 2.8 has been displayed. So CPU load matched. You can even verify it here. Chrome, yeah, the CPU is 2.8%, right? So it actually matched this. CPU load matched, right? So this is how you need to write the logic. So only new thing was following sibling here. So this is because like in the same row, so if it has like a following siblings, we captured it, and from it, so it has multiple TDs, 100, each TD representing one cell value. So we wanted a cell value which contains percentile. So that is what we got it and have it in the CPU load. And then we compared it with the actual label which is present at the end. That's all. It's simple logic. Is that clear? Great. So there is one more thing called, so this is all about dynamic web table, right? So data will be dynamic, and rows and columns are not fixed. It can even have uneven columns and rows, right? Data will be dynamic. Uh, the order, right? Order, order of rows and columns are also not fixed, right? So all this comes under dynamic web table. So there is one more concept called pagination. So let's actually complete this so that we'll complete this web table. So I don't want to have this in another session. It will only take 10 to 10 minutes maximum. So let's actually discuss about pagination as well. So pagination is also a same kind of like it's also a web table. The only thing is like it will have pages. So if you have multiple rows, several rows, right? So how do you actually represent the data? Then you have to represent it in the different tables. So different tables you need to represent the data. For example, let me show you. say for example, so this is my data, right? And I wanted to display it. So it has multiple rows, right? So these are the entries. See, 1 to 10 of 57 entries. So all the 57 entries can't be shown within this table. It can only show at a time 10 entries, right? So in that case, you will be having the pagination. Pagination in the sense, the same, all the data can't be represented in one page. So it is divided into multiple pages. So if you see here, 1 to 10 of 57 entries, right? So if you wanted to read the more 11th to 20th row, right? So then you have to click on the second page. Then if you wanted to read more number of rows, then you will click on the third page, fourth page, and so on, right? Till the last page, you can read the data. So each page will have 10 entries, right? So how do you actually read the data? So you read this data using Selenium. Then you wanted to read more data. So then what you can do, you can click on this second page. So this we need to automate. So this you actually loop it. You till now what we learned. We learned to read all these records within this web page. So we'll write a small logic after reading all the records, right? So end of the all rows. So we know we came to the end of the row, but still we have more rows. So how do we read more rows? We know it has a pagination. It has more rows and it has pagination. So this button we'll inspect, we'll locate this button and we'll click on it. And then the loop continues again. We'll read all the rows. And then once we come to the end, we'll know we came to the end of the rows, end of this page, and then we'll click on this third page like that. So this we need to automate. So this is what we call it as pagination, and this is what we need to automate newly in this example, right? So we'll take a small example. So if you see here, this web page has a pagination table. It's a simple one, right? So let's take this. So if you see here, it has some items here, some product, some ID, name, price, right? And some select with checkboxes. We can just ignore it for now. So if you see name, product 1, 2, 3, 4, 5. So it has more number of rows. So if you see, if you click on this second page, it will have more number of rows, 3, 4, 4 pages. So it has data in 20 records in it. So all the 20 records were not displayed in the same web table. So web table was designed to hold only 5 records at a time. So first table has 5 records. If you wanted to read more number of records, you'll click on the second page, third page, fourth page, and so on, right? So this we wanted to automate, right? And print it on the console. Or we can take some condition, like, I wanted to check some product, say for example, some product 13, if it is present in the web table or not. So it is not present in the first table. So you should not say that it is not present. You have to click on second page, verify the product is present or not. Click on third page and then verify the product is not present or not till the last page, right? If the product is there, you can just come out of the loop. So that's the logic we'll write it now, right? So let's create a new class. I'll call it as pagination table. As it will anyway be like same as the previous example. So just in the interest of time, what I can do is I'll just have the code written here and then we'll go through the code. So first part, what we do is, you don't need all this. So we'll have a WebDriver instance and then we are using implicit wait here. So because if you click on one page to other page, it takes some time, right? So we added implicit wait here and we navigated to the particular website. We maximize the window. This is all routine, right? And then what we do, we actually locate the table. So locating the table is this we have seen, right? So till here we have seen. We wanted to read the only data now. So I have given the t body also here. Find element, right? So it will be a web element till here. So if you observe, that will be the ID. I'll even show you that. So if you see th, tr, thead, it also has thead and tbody, right? It's a table with an ID product table. It has thead, tbody. For now, just forget about thead. We'll concentrate only on tbody, on the data, because we wanted to find a particular product, right? A product, particular product we wanted to find if that is present in the web table or not. That will be our validation, right? So if you see in this, within this tbody, it has only 5 TRs, but this represents UL represents this pages here. See, this UL class equal to pagination, ID equal to pagination. So if you expand this, it has 4 LIs. Each LI is representing one page. So if I wanted to click on this second page, it is LI anchor tag within it 2, right? Likewise, 4 pages, 4 LIs here. So we need this one. The main part here is everything will be the same, like the previous example. It is nothing new. You can just display the data also in the same way as this earlier example with the headers also, right? The only new thing here is pagination. So let's concentrate on pagination now. So if you see this is the pagination locator, right? UL. So under UL tag, we have 4 LIs, each one representing one page, right? So this we need to get it. Like if you see here, this is the related XPath, and if you click on this, one element matches, so the whole part. But underneath it, it has 4 LIs, each one representing one page. So you can get this. So in order to navigate to each page, what you can do, this is first page, 2, third LI, like that. Go on. So 3, 4. So this is how you can loop through each page. So this is the XPath of it. So if you can see here, so we have the table here with t body, all right. And yeah, we'll come, we have this Boolean just to write the logic if the product is found. So we wanted to verify, right? So if the product is present in that web table or not. So for that, we have taken a Boolean variable and we have assigned it to false. All right. Now we wanted to calculate the total number of pages. So this is the XPath we copied from here, right? So you can see here, this actually represents the pagination and all the pages here. So we are representing it with the XPath and we are finding the size of it. So here in XPath, it's showing 4 elements matching, right? So that you can get it using the size method. Find elements dot size will actually give you the number of elements in it, right? So that we captured into the total pages. And we are starting with page 2 here. So because you'll come to know that, right? So if you see here, I'm writing a do while loop. So even you'll get it why we written do while loop, right? So first enter into this loop. So you see table, right? Table dot find elements of tr. It will actually give you the table records or table rows, right? Under this table. So that's what we did in the earlier example also, if you see, right? Table dot find elements, right? So in the same way, we actually did this tr, right? We got the rows. All right. We got the rows. Once we get the rows, we are iterating it in the for each column, right? So for each row from the rows, so row dot find elements of TD. So each row TR, we wanted TDs under it, right? So we have the rows here, and for each row, what we wanted to do. So once you enter into this loop, so it is representing one row, right? Under that row, first row, say for example, we wanted to read all the TDs, right? So TDs will be, one TD will be one web element. So we wanted to know, get all the tags names with TD. So we capture it into the list of web elements. So cells represent for a particular row, all the cell values, right? So from all the cell values, we are interested only to get the first index one. So first index represents second column because cells here are list. List index starts with 0. So 1 represents second column. Get value from the second column, that is name. Name here, right? All right. So once you get the text of this, that is a cell value. You can call it as a name or product value as well. So I'm displaying that value here. And then we are writing this small logic here. So cell value dot equals product 19. Okay. So product 19 we wanted to find because it's present in the fourth page. So it will navigate through fourth page. We can see that in action. So cell value dot equals product 19. We'll just say product found, and this product found is a Boolean value. We'll say true, and then we'll break. We don't need to navigate, or we can just say product 13 first, right? So then break. It is found in, it should be in the third page, I guess. Yeah. Once it is found, we don't need to iterate through it. So we just come out of the loop. So it will be, it will break. It will break this loop. So once it breaks this for loop, so it will come here and we will verify if is product found or not. If it is found, right, so it enters into this loop and it will actually modify this value to true. If it is true, it will again break out of, again we will break this do while loop as well, right? So say for example, if it is not found, in our case, it will never find, it will not be there in the first page anyway. So in that case, what I have to do, you have to click on this second page and verify these values, right? So for that, we have written the logic. So it will not enter into this because it will not enter into this loop. Product 30 is not found. So is product found will still be false, right? The initial value of is product found is false, right? So it will not enter into this for the first time. Then what happens? Or else what we can, yeah, first let me explain. It will not, so it will not enter into this loop. If product is false. So if false, so it will not enter into this loop as well. So it will go to the next page. So how do we write the XPath here? So if you observe driver.find element, list of page number, right? Page, we have initialized its value to 2 here. Because, so till here, it will be reading the first page, we know, right? It should start with the second page. It will should click on the second page, li of 2. So if you go back, li of 2 is representing second page. See, it has to click on this. So this is the reason we have written the find element XPath like this. So this will be the next page. And we wanted to look at it. So I have added some wait time here. And we'll click on the next page. So which will take you to the next page. Wait for the next page to load, right? Then that's it. So we'll go back again. So to go back, we have entered the while loop here, do while loop. So do while loop, then we'll check the condition here. If the page is less than or equal to the total pages. Total pages we have calculated here, the size of it. It will be 4 in this case. So 2 less than or equal to 4 will be evaluated. It is true. So it will go back to the do while loop again. So again, it will continue for each row. So this is all the same story, like each row and each column. Till here it is same, and here it will verify the cell value is equal to product 13 or not, right? If it is not found, again, it comes here and goes to the, this time page is increased, see, page plus plus. So it will be 3. It will actually click on the number 3, third page, right? It will click on the third page. It will see here 3 less than or equal to 4 is true. Then it will go back again, the same story. This will be repeated till it is found. If it is found, then it will actually say is found equal to true, right? And then is found equal to true will become true, so it will break it. So it will come out of this do while loop. You will not iterate more. Say for example, if it is not found, right? So this page will exceed. This will become 4 and next time it will become 5. 5 less than or equal to 4 will be false. So this will never enter into this is product. It will still be false, right? So that condition we have to verify once we come out of the loop. If is product, we have used the negation. So if it is not found, is what we are verifying. Then we'll say product not found in the table. If it is found, right, so we'll just skip it. We have already written the product found logic here. So you can go through this logic once. I'll run it and show you. You can go through the logic and yeah, you can debug it even. You'll get it. If you are not getting it, we'll discuss in the next session. Simple logic. So by this time, you should be clear on like how to display the cell values in the format of row by column, right? So that's very simple. Only thing is writing the logic, right? So if you see here, yeah, see, it went to second page. It didn't find it. It goes to the third page and it found it, product 13. And you can see the data also, right? Display product 1 till product 13 it displayed and product was found. So it just came out of the loop. like this, you can run it for multiple values and verify. I'm intentionally I give it product 19 because it can navigate till last page. So once you write the logic like this, right? So you have to validate it for different values. So first page value, last page value, in between value, and for a product which doesn't exist like that, you have to verify for multiple values to validate if the logic which you have written is right or not. See, it verifies second page, it is not present. It verifies third page for product 19, it is not found. It goes to page 4, it is found. So it will just display product 19, product found. You can just give it some product 100 like this. Product 100 is not present in that web table, right? So it has 4 pages, but that product is not present. So what it has to do? It has to say, it has to go through all pages, verify all the values, and if it doesn't match with any of them, it has to return product not found. We'll see that now. So it verifies the first page, then goes to the second page, third, and fourth, and that's it. It is not found, right? So it should say product not found. Oh, it is giving some error. Oh, it is going to li5 as well. It should not go to the li5 because page plus plus we have written, right? So this will become 5. Okay, 4 less than or equal to 4, right? 4 less than or equal to 4. Then after we check this condition, it will be incremented. So it will become 5, and it was trying to verify this, right? So it is trying to click on this page 5. So it was not there. So it was returning some error. So in that case, what we can do is we can write a logic like this, right? So you can go for loop instead of do while loop. So this time it will actually stop to less than or equal to 5. So less than or equal to 5 is like, it will actually verify this for till last page. 2, 3, 4, and then if it is 5, right? So 5 less than or equal to 5 will be true. So it has to actually run it till the last page, till here. Right? So like this, you have to modify the logic according to your requirement, right? So and validate it if it is actually working for all the values or not, right? So you can go through the logic, and if you have any questions, right? So if you didn't get it or if you have any questions, we'll discuss in the next session. So any questions? Everything clear? All right then. Yeah, you can see that here, right? Yeah, this time it will say product not found in the table, right? So yeah, because product 100 is not present, right? So you can go through the logic, and yeah, if you don't get it, we will discuss in the next session. All right, then I'm stopping here if you don't have any questions.